Okay, let us continue the third part of today's class. Okay, please turn to the slides. Okay, we have talked to this page. Okay, Gaffney and Cohen. Okay, they have published a paper titled Learning in Restless Multi-Armed Bandits Using Adaptive Arm Sequencing Rules in Proceeding of the IEEE International Symposium on Information Theory ISIT, okay, in 2018B. And 2018A is called the Learning in Restless Multi-Armed Bandits via Adaptive Arm Sequencing Rules, okay, submitted to IEEE Transactions on Automatic Control 2018A. Okay, actually, this paper has been published. Okay, you can search it on the web. Okay, like this. Okay, so this paper is already published, okay, in IEEE Transactions on Automatic Control in 2021. Okay. Okay, to design effective learning strategies for DSA. Okay, do you remember what is DSA? Okay, let us review what is DSA. Okay, let us use the searching. Okay, DSA. Okay, the DSA means the dynamic spectrum access. Okay, so let us go back to page 25 and continue. Okay, in this chapter we focus on this definition of regret. Okay, so next we are going to a new subsection, section 1.2.3, the objective. Okay, as explained in section 1.2.2, okay, this section, okay, the formal section, we define the regret R phi of t for policy phi as the difference between the expected total reward that can be obtained by using the channel with the highest reward mean and the expected total reward obtained from using policy phi up to time t. Okay, that is R phi of t is equal to t times mu sigma 1 minus the expectation of capital R of t with respect to phi. Okay, so where t denotes the time, okay, this t denotes the time. Okay, do you remember what is mu sigma 1? Okay, let us review what is mu sigma 1. Okay, so on page 17, okay, here is the answer. We define the channel index permutation of 1 to k, capital K is the number of the channels, by sigma such that mu star is defined as mu sigma 1 is greater than or equal to mu sigma 2 is greater than or equal to dots is greater than or equal to mu sigma k. Okay, then what is mu I? Mu I is the stationary reward mean, okay, which is defined in this equation. Okay, so minus the expectation. I think you already know what is expectation because you have taken the course probability when you are a university student. Okay, the expectation of capital R of t. Okay, what is capital R of t? Okay, let us review it. Okay, capital R of t is the total reward by time t, which is defined in equation 1.2. Okay, on page 18. Okay, and with respect to phi, the object is to find a policy that minimizes the growth rate of the regret with time. Achieving this goal requires designing a strategy that effectively addresses the well-known exploration versus exploitation dilemma in online learning problems. Okay, we have introduced what is the exploration and exploitation dilemma. Okay, if you forget it, please turn to the handout and search for the exploration. Okay, here. Exploration, exploitation, trade-off dilemma. Okay, so on the page 15 of the handout, you can review what is the exploration, exploitation, trade-off dilemma. Okay, next, on the one hand, the cognitive user should explore all channels to learn their unknown states. On the other hand, it should exploit the inference outcome to use the channel with the highest mean. Since the wireless channels are restless, what is restless mean? What does this mean? Okay, that is, both active and passive arms are restless in the context of the RMAB model. The design strategy should learn the Markovian reward statistics consecutively for a period of time, that is, epoch. This will avoid the potential reward loss due to the transient effect as compared to steady state when switching channels. Okay, in this subsection, this is a subsection 1.2.4, random and deterministic approaches. We overview two algorithms that were developed in recent years to achieve the objective just described. The first uses random epoch lengths, dubbed. Okay, what is the meaning of dubbed? Okay, please see the handout. Okay, so we can search for dubbed. Okay, what is dubbed? Okay, answer. Past simple and past participle of dub. Okay, problem 2. What is dub? Answer. To give something or someone a particular name, especially describing what you think of it, him or her. Okay, this is dub. Okay, dubbed the regenerative cycle algorithm, RCA. Please see Taking and Liu in 2012. Okay, Taking and Liu in 2012 is this paper, Online Learning of Rested and Restless Bandits. published in IEEE Transactions on Information Theory in 2012. Okay, and the second uses deterministic epoch lengths, dubbed the deterministic sequencing of exploration and exploitation DSEE algorithm. Okay, please see Liu et al. In 2013. Okay, here is Liu et al. In 2013. Okay, learning in a changing world. Restless multi-armed bandit with unknown dynamics. IEEE Transactions on Information Theory. The idea of the RCA algorithm is to catch predefined channel states each time the algorithm enters a transmission epoch when using a channel. Okay, these catching times are called regenerative cycles and are defined by random heating times. Okay, do you remember what is heating time? Okay, I have taught this to you. Okay, if you forget what is the heating times, okay, please turn to the handout and search for the heating time. Okay, heating time. Okay, what is heating time? Okay, you can find the definition of the heating time on page 13 in the handout. Okay, back to the slides. Okay, the channel selection is based on the upper confidence bound UCB index. Okay, please see Auer et al. 2002A. Okay, we can see that Auer et al. 2002A is a paper titled Finite Time Analysis of the Multi-Armed Bandit Problem, which is published in Machine Learning. Okay, then what is the upper confidence bound UCB index? Okay, please see the handout. Okay, we need to search for the UCB. Okay, what is upper confidence bound UCB index? Answer: this is beyond the scope of this course. Please see reference 71 for details. Okay, let us see reference 71. Okay, reference 71 is a paper written by Auer et al. Called Finite Time Analysis of the Multi-Armed Bandit Problem, published in Machine Learning in year 2002. Okay, let us go back to the slides. The authors showed that RCA achieves a logarithmic scaling of the regret with time. Okay, I think you already know what is the logarithmic. It is the log function. However, since RCA performs a random regenerative cycle at each epoch, the scaling with the mean heating time m is of order big O of m times log t. Okay, what does this mean? Big O. Okay, it is a very important notation, and please see the handout and search for the big O. Okay, O. So I need to, okay, I find this. Okay, so what is big O? Okay, answer. Let f be a real or complex valued function and g a real valued function. Let both functions be defined on some unbounded subset of the positive real numbers, and g of x be strictly positive for all large enough values of x. One writes, f of x is equal to big O of g of x as x approaches infinity. Big O notation has two main areas of application. Okay, in mathematics, it is commonly used to describe how closely a finite series approximates a given function, especially in the case of a truncated Taylor series or asymptotic expansion. In computer science, it is useful in the analysis of algorithms. Okay, please see reference 72. Okay, reference 72 is the big O notation, the item of the Wikipedia. Okay, let us see it. Okay, big O notation. Okay, if you have interested in it, you can read this page. Okay, this page contains many interesting materials here. Okay, let us go back to the slides. So the DSEE algorithm overcomes this issue by avoiding the execution of random regenerative cycles at each epoch. Instead, the idea behind DSEE is to use deterministic sequencing of exploration and exploitation epochs. It has been shown that by judiciously, okay, do you remember what is the meaning of this word? Judiciously. Okay, actually, I have told you what is the meaning of this word. Okay, if you forget it, please turn to the handout and search for the okay, I got it. Judiciously. Okay, on the page 5 of the handout, judiciously. Okay, back to the slides. Okay, judiciously designing these deterministic epochs, a logarithmic regret with time is obtained. However, the design of these deterministic epochs by DSEE requires oversampling. Okay, what is oversampling? Please see the handout. Okay, search for okay, here, oversampling. Okay, what is oversampling? Answer: in signal processing, oversampling is the process of sampling a signal at a sampling frequency significantly higher than the Nyquist rate. Okay, then what is the Nyquist rate? Okay, what is Nyquist rate? In signal processing, the Nyquist rate, named after Harry Nyquist, specifies a sampling rate. Okay, in units of samples per second or Hertz, Hz, equal to twice the highest frequency bandwidth of a given function or signal. Okay, back to the slides. Okay, oversampling bad channels for transmission to achieve the desired logarithmic regret. Okay, this oversampling results in a scaling order of big O of 1 over the square root of delta plus k minus 2 over delta times log t. Okay, where capital K is the number of channels and 0 is smaller than delta and is smaller than mu of sigma of 1 minus mu of sigma of 2 squared. Okay, we have reviewed what is the mu sigma of 1 in this part. It's a non-lower bound on the square difference between the highest reward mean, mu sigma of 1, and the second highest reward mean, mu sigma of 2. Okay, when the channel state space increases or when the probability of switching between channel states decreases, then the mean heating times of catching predefined channel states increases, which decreases performance under the RCA algorithm. On the other hand, increasing the number of channels K when mu sigma of 1 minus mu sigma of 2 is small as compared to the differences between mu sigma of 1 and the reward means of other channels decreases performance under the DSEE algorithm. We next overview a very recent algorithm that we developed to overcome these issues. Okay, this is called the section 1.2.5, the adaptive sequencing rules approach. Okay, in Gaffney and Cohen 2018 B and A. Okay, let us see Gaffney and Cohen in 2018 B and 2018 A. Okay, these two papers. We have talked about it today, earlier. Okay, the authors developed the adaptive sequencing rules ASR algorithm for solving the RMAB problem for DSA. The basic idea of ASR is to estimate the desired unknown exploration rate of each channel online during the algorithm to achieve efficient learning. This approach avoids oversampling bad channels as in DSEE, and at the same time it significantly reduces the total amount of regenerative cycles as required by RCA. Specifically, the authors show in Gaffney and Cohen 2018 BA that we must explore a bad channel sigma of I is equal to 2, 3 to capital K, at least d bar I times log t times, where d bar I is defined as 4L over mu star minus mu sigma of I squared. Okay, do you remember what is L? Okay, let us review what is L. Okay, L is defined in equation 1.1. It is 30 times R max squared over 3 minus 2 times the square root of Okay, it is 25 minutes now. Let us take a break.